Hello everyone, I'm Adarsh, an undergraduate electric and electronics engineering student from PSG Institute of Technology and Applied Research, Tamil Nadu, India. In this video, I present an adaptive cruise control system with an emergency braking override implemented using MATLAB Simulink and model predictive control. Adaptive cruise control is a widely used driver assistance feature that automatically adjusts the vehicle speed to maintain a safe following distance. However, in real-world driving, sudden brake by the lead vehicle introduces a safety critical scenario where the controller must respond immediately. The proposed system consists of three main components: a longitudinal vehicle dynamics model, which is currently shown, an MPC-based adaptive control system, and an emergency braking logic implemented using MATLAB function block. The ego vehicle are modeled using basic physics where the acceleration is integrated to obtain speed and speed is further integrated to obtain position. This simplified modeling approach allows us to focus on control and safety rather than the vehicle complexity. Model-based predictive control is chosen because it can anticipate future behavior by predicting system states over a finite horizon. At each step, the MPC computes an optimal acceleration command that attempts to maintain the desired intervehicle distance while respecting acceleration and braking constraints. In addition to MPC, an emergency braking logic is also implemented to handle extreme situations. The logic continuously evaluates the risk of collision using distance and relative speed information, commonly represented as time to collision. When the calculated risk exceeds a predefined threshold, the system overrides the MPC output and applies a strong braking command to ensure safety. Now, let me explain the behavior of the model. Looking on the first graph of lead speed, which is directly linked to scope 1. This plot shows the lead vehicle speed profile. At 5 seconds, a sudden stop is introduced to simulate an emergency braking scenario. Now looking on to the scope 3 linked to ego speed, the ego vehicle initially follows the lead vehicle speed smoothly under MPC control. When emergency conditions detected, the ego vehicle rapidly decelerates, indicating the activation of emergency braking. Looking to the scope 2, which is the importance of distance. Despite the sudden stop of the lead vehicle, the inter-vehicle distance is shown in the graph, demonstrating the effective collision avoidance. This confirms the emergency braking is successfully applied at all scenarios, which enhances the adaptive cruise control system.